Hi friends, welcome to GMK tutorials. In this video, we are going to see about the histogram equalization. Okay, so let's move on to this one. Histogram equalization. Generally, we know that histogram means that histogram is equal to in our previous discussion, we know that histogram can be represented as h of rk. H of rk is equal to nk, where nk is nothing but the kth pixel is repeated kth intensity value, and nk is the number of pixels in the image with intensity rk. Okay, so that is nothing but generally nk is nothing but number of pixels. Nk is equal to number of pixels with rk. Okay, that is generally called as a histogram. Suppose if you are taking is a 10 is a number, 10 is intensity, this 10 intensity value can be repeated 20 times. This is generally called as a histogram. This single value is generally called as a bin. Now our topic is histogram equalization. Okay, so or else we can also define the another normalization means that can be represented as p of rk. This is nothing, p of rk is equal to histogram nk by total number of, n is nothing but total number of pixels. Maybe some of the textbooks it can be represented capital M into capital N, where we know that capital M is nothing but number of rows and capital N is equal to number of columns. Okay, so that is just a brief introduction about what is meant by histogram, how we are going to represent the histogram, and what is meant by normalized histogram. Generally we are prefer normalized histogram in the many of the applications. Okay, then let's move on to the histogram equalization concept. In case of the histogram equalization, we are considering two variables. R is the input pixel. The range of R values is nothing but 0 to L minus 1 only. Okay, where 0 represents black, L minus 1 represents white. Okay, represent, as well as we know that this transfer function s is equal to t of r, where r is nothing but input image pixel, and s is nothing but output pixel. That is the basic. So in this case it satisfies two criteria, that is nothing but first one is nothing but tr of r. First one is nothing but condition number 1, tr of r must be monotonical function, is a monotonic function, as well as second in the range of from 0 less than r less than L minus 1. At the same time, second condition is nothing but b is equal to, that is nothing, condition b, that is nothing but 0 less than tr of r less than or equal to L minus 1. So the first function means that means the first condition states that tr of r must be monotonical, means that the output intensity values will never less than that of the corresponding input value. That means output values may not be decreases compared to the corresponding input intensity value. Second condition B states that the range of the corresponding output values also within the range of the input, that is nothing but 0 to L minus 1. That's why these two are the most important considerations in case of the histogram equalization. Okay, so let us see here. Generally, so from the probability of definitions, if r and s variables are continuous variable, at that time it can be represented as ps of s, that is nothing but ps of s value is equal to pr of r into dr by ds. Okay, So we know that generally S is equal to, we know that S is equal to TR of R, that value is also equal to L minus 1 from 0 to R PR of W into dW, where omega is nothing but W is nothing but a dummy variable. Moreover, L minus 1 is used to maintain the corresponding value. As the R value increases, the corresponding value may not be decreases to 0. So for that purpose, L minus 1 is also maintained in the same equation. Now we have to find out the ds by dr. ds by dr is equal to generally S is equal to TR of R, right? So from that you have to represent d by dr of L minus 1 into 0 to R into PR of R into d omega, right? Where this integration and differentiation both are get cancelled. Moreover, L minus 1 is a constant value. So from this we are getting L minus 1 into PR of R. This is the equation for ds by dr. Okay, this is the equation for ds by dr. Now the another variable is nothing but we know that generally PS by PR, we know that PS is, so in the previous discussion okay, we know that the equation, but generally we know that so ds by dr is equal to L minus 1 into PR. So from this equation, generally we know that from this equation PS of S is equal to PR of R into dr by ds. Actually we are getting, we need dr by ds, but we are finding ds by ds. So if you are opposing this one, you will get dr by ds. Okay, that is the basic thing we have to remember here. Wait a minute. So we need PS of S is equal to, PS of S is value is equal to PR of R into dr by ds. Okay, we know that generally ds by dr value is equal to 1 by L minus 1 into PR of R, right? So if you are reversing this one, we are getting dr by ds is equal to 1 by L minus 1 into PR of R. Now if you are substituting this equation in this equation, we will get PS by S value is equal to PR of R into 1 by L minus 1 into PR of R. This PR of R get cancelled. Therefore we can get PS of S value is equal to 1 by L minus 1, right? This is the finalized equation. So from this equation what we are getting here is PS of S is the equation is uniform probability density function. Simply stated that the PS of S value always uniform independently of the form of PR of R. We are not considering about the PR of R, in respect of the PR of R, we are getting the corresponding values some uniform manner. That is the basic intention behind the histogram equalization. Generally, if you are closely observe this one, there is some statements will be there. Actually, the histogram matching is a histogram. One more problem in case of the histogram equalization. Suppose if you are observe this equation graph, actually, let us consider scenario. This is nothing but TR of R function. Okay, if you want to same TR of R, if you want to performing the same mapping here SK values, so these are the some of the constant values. These constant values can be mapped into the single location. If it is a monotonic function, these are all values are mapped to the single location, that is nothing but SK. But we are getting SK is equal to multiple values. So multiple values are mapped to the single function means if you want to get the reverse operation, it is one of the problem actually. So that is also one more drawback in case of the histogram equalization. Suppose if you want to analyze in case of PR of R, so if it is a PR of R value is equal to, if you observe this equation is a graph like this, if you are mapping this one to the PS of S value is equal to like this, L minus 1 1 by L minus 1. Okay, this is the PS of S. That means irrespective of the shape of the PR of R, P of S produces some uniform value. So that is nothing but if histogram equalization. Okay, if you want to represent the same equation in case of the digital domain, just you have to replace the corresponding values with that is nothing but SK is equal to TR of RK. That value is equal to L minus 1 into summation J is equal to 0 to K into PR of RJ. Just notation changes. In the previous case we can consider RK, here we will consider RJ. That is the only difference. L minus 1 into by Mn, it is nothing but number of pixels, total number of pixels. J is equal to 0 to K, it is nothing but Nj. Nj is nothing but histogram of the corresponding discrete time equation. Okay, so the transfer function TR of RK in this equation is called as histogram equalization, or we can also call it histogram linearization. Okay, the function TR of RK is called histogram equalization. We can also call it as histogram linearization. So this is about the histogram equalization concept. Okay, so thank you for watching GMK tutorial guys. Thanks a lot.